We bounced quickly from Chapter 11 to Chapter 13 for a reason. In Section 13.1, we're going to see how we can use our newfound completing the square skills to help us sketch the graphs of a couple other kinds of shapes. One kind of shape that we're going to sketch, and sketch it first, are parabolas that open up to the left or open up to the right. And the second kind of shape we're going to learn to sketch are circles, and eventually we'll use completing the square on all of these. So notice that y is not by itself. Notice x is by itself on this parabola, and that means it's going to open up one of these two directions. And so what we're going to do is we're going to complete the square much the same way we did before, but everything's just sort of slightly backwards, so to speak. And so let's see what happens. Here, we take the 2, we cut it in half, we multiply it by itself, and we get 1. So we're going to add 1 here, so we're going to have to subtract 1 here. These should seem like familiar kinds of steps. Now we got a question. What is the vertex? And that's kind of an interesting question. Think about it a minute. Well, it would seem like the y number that makes the parentheses 0 is -1. So that would be the y value of the vertex. And notice if you put a -1 in there, this becomes 0. And x equals 0 minus 2, which is -2. And so this would be the x value of the vertex. It seems as if that's reasonable. So we have a -2 here and a -1 here, and there seems to be the vertex. And since there's a 1 here, it no longer opens up. When this is a positive number, it opens positive in the x direction. And when it's a negative number, it opens negative. So this is going to open up to the side and be kind of normal thickness. It's going to be something like this. Now let's go test that out in Desmos. So I just went over to Desmos and put in the graph, sure, the vertex is at -2, -1, and it does open to the right, and it does have normal thickness. And Desmos is a really convenient, fast tool to use to double check our ideas. The next shape we're going to learn about is a circle. A circle has two key things. It has a center and has a radius. The radius is how far you go out in any direction to get to the circle itself. So the radius, the length of the radius is like the length of a spoke on a wheel. So the most basic kind of problem of all is to be given the center and given the radius and try to build an equation. Well, the basic idea of the equation of a circle is this. Where h and k are numbers that are involved with the center of the circle, and r is the radius of the circle, and each of these things is squared, and this is a plus, and that's a lot of knowledge, but you get used to it pretty fast. So we're going to have something squared plus something squared equals some number squared. That's what we're going to have. And that number that's being squared is always the radius number. Always, always, always. Here, these always start out with x and y, and this number, the x value of the center, has to be the number you could put here that makes this 0. So imagine that. If we're going to put a 3 in for this x and get 0 here, what has to go with it? Well, it has to be a -3. So think about that. If I make this be x minus 3, does this x equals 3 make this whole thing 0? Yeah. Now, what about the -5 for y? When you put it here, it has to make this whole thing 0. So this is going to be +5. So some students kind of memorize that it's kind of the opposite of the center. If the center has an x value of 3, you put an x minus 3. If the center has a y value of -5, you put a +5. And it's true. These numbers will be opposites of these numbers, but the reason is the numbers that are the center of the circle should make each of these 0. And so this or this is the equation of a circle that has this center and this radius, and of course we can check it out in Desmos pretty easily. So let's see here, I put in the equation of the circle that we got, and it's in red and you can see it, and then I just put in a 0.3 negative 5 just to make sure that was the center. Does it look like the center of the circle to you? Yeah. Does it look like the distance from the center to the right hand edge is 4? Yeah. To the left hand edge 4, down 4, up 4. And even diagonally, although that would be hard to show and we don't really need to show it, but diagonally it would be 4 as well. So do we know this forwards and backwards? If we have the equation of a circle, can we write down the center and the radius? Well, maybe so. The center's x value has to make this 0. The center's y value has to make this quantity in the parentheses 0. And the radius is always the square root of that number, so it's the square root of 15, which is almost 4. So the radius is almost 4, and the center is at negative 5, 1. And if we had to sketch it, which we don't, but if we had to sketch it, it would be at negative 5, 1. That would be the center. And then it would go 4 in each direction, and so it would look something like that. All right, let's go to the next one. So how are we going to graph the equation of this circle? It's got an x squared and a y squared in it, so we think it's going to be the equation of a circle. And the answer is we got to try to get it into this shape. And to do that, we're going to have to complete the square a couple of times. And that's just kind of a weird process, so let's get started. So I subtracted 12 from both sides to put that 12 far away from the action, and I have x squared plus 6x and a blank, and y squared plus 4y and a blank. And now I'm going to complete the square on this blank. I write down the coefficient of x, I cut it in half, I multiply that by itself, and I get 9. So I'm going to add 9 to this side, but to keep it balanced, I'm going to come to the other side of the equal sign and add 9. If you take away 9 from both sides, you get back to where you started. Here, I'm going to take 4, I'm going to take half of 4, and I'm going to multiply it by itself and get 4, which is kind of weird. But that'll make that a perfect square, and then I'll add 4 over here. Now this is x plus 3 times x plus 3. We completed the square, we made it be a perfect square. This is y plus 2 times y plus 2. We made it be a perfect square. And this is negative 12 plus 13. So now we know the center. The center is negative 3, negative 2, because the negative 3 makes this quantity in the parentheses 0. The negative 2 makes this quantity in the parentheses 0. And the radius is always the square root of this number, and the square root of 1 is 1. So if we're asked to sketch the graph of this circle, it would be at negative 3, negative 2, and it would have a radius of 1. So it would look about like that. And we're done.